Okay, so for another case of what we have in converting from standard to vertex form, and let's say that if we were to determine the vertex and we'll say that we have the function f of x is equal to x squared minus 10x plus 17. Again, this is a standard form of the quadratic function. Okay, and if we look at creating the pathway to translating to what we have in the vertex form. Okay, so we have f of x is equal to x squared minus 10x plus 17. And again, in creating the pathway to the determination of the vertex form. Okay, so if we separate the variable terms apart from the constants, okay, so you have x squared minus 10x quantified in parentheses, then we have plus 17 at the end. And again, if we look at the completion of the square, CTS for complete the square, so again we have with x squared minus 10x, so if we take the coefficient of the first order variable term, so again we take half of negative 10 and square, half of negative 10 is negative 5, and the square of negative 5, okay, is going to become 25. And so in taking what we have now, we have f of x, and we have is equal to x squared minus 10x and so here we're going to add 25, and again to neutralize, again I still want the equivalent of x squared minus 10x plus 17, but right now upon adding 25 at the front I have 42. So to neutralize, I'm going to deduct the same amount at the end. So in making the adjustment, so we have f of x is equal to x squared minus 10x plus 25. 17 minus 25 is negative 8. And again, for x squared minus 10x plus 25, okay, that is going to be a squared trinomial. From x squared I have x, and once again we have for 25, okay, I had just squared out negative 5. So x squared minus 10x plus 25, okay, again that is going to be the square of the binomial x minus 5. So we're going to have, in the case of the vertex form, again I have f of x is equal to the square of x minus 5 minus 8. And so for what we're going to have in this setting, okay, so I have a is equal to 1, h is equal to 5, and we have for k, I have negative 8. And so we have officially for the coordinates, okay, of the vertex, we end up with the ordered pair 5 and negative 8. Now, just one more portion here, and this would be where we have forming polynomials from given zeros. And degrees. And I'll say as an example, and let's say that if we have to form a polynomial in expanded form, and we have given the items of information. And we'll say that we have zeros, okay, where we have at -2, 0, and 3. And we'll say that for the degree of the polynomial, okay, that is going to be at 3. All right. And in terms of the setup, now for forming the polynomial, we say that we have zeros have -2, so we can just think of this like setting up solutions. You have like nx, have x is equal to -2, x is equal to 0, and x is equal to 3. Now, if I set up a polynomial, and we can take, in the case of the factored form, think of it in the manner of the zero product property taken in reverse. So we can say that x equals -2, so we can say that originates from, say, a binomial along the lines of x plus 2. Okay, so this is one form. You might have 2x plus 4, 3x plus 6, but the most basic, we'll just go with x plus 2. So like if x plus 2 is 0, x is equal to -2. And for x is equal to 0, well, you're not adding or subtracting anything, so we just go with x. And for x equals 3, we can say that is going to be the solution to the binomial x minus 3, or any multiple thereof. So we have, so if x plus 2 is 0, x is -2. Again, we have x if that is 0. And for x minus 3, if that is equal to 0, well, we have x is equal to 3. Now for the expanded form, now you can multiply the factors in order from left to right. Now if I multiply together x plus 2 and x times x plus 2, we'll have x squared plus 2x. And if I multiply by the remaining factor, x minus 3, so we have in the setup and utilizing, let's say, the FOIL method, we have x squared times x. So the first product is going to be x cubed. Outside product, we have minus 3 times x squared. Inside product, we have 2x times x, so it'll be plus 2x squared. And for 2x times -3, we have minus 6x. And so for third order polynomial in expanded form, we have x cubed, and what's going to be minus x squared minus 6x. And now if I were to plug in -2, 0, or 3, like f of -2, if I plug in -2 for x, f of -2 would come out to 0. F of 0, got 0 minus 0 is still 0. And say for f of 3, say like 3 cubed is 27, 3 squared is 9, and 27 minus 9 is 18. And guess what? Minus 6 times 3 is going to be minus 18. 18 minus 18 is 0. So this is a case of what we have for forming a polynomial in standard form on the basis of given zeros and degrees.